Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 81 to the power of sine square x plus 81 to the power of cos square x is equal to 30, and we will solve this problem for the value of x. So the very first thing we are going to do is, here first I can make the factor of 81, and you know that the factors of 81 are 3 to the power of 4 and its whole power sine square x, plus similarly here you have 81. Similarly we have the factors of this 81 are 3 to the power of 4 and its whole power cos square x is equal to 30. After this step we will use here the nice exponential law, and you know that if we have a to the power of m to the power of n, so it is equals to a to the power of m times of n. So now we use this exponential law, so that after applying this exponential law we get the output in the form of 3 to the power of 4 times of sine square x plus 3 to the power of 4 times of cos square x is equal to 30. In the next step we will convert this cos square into the sine square form, because you know that cos square is equal to 1 minus sine square, so that this will becomes 3 to the power of sine square x plus 3 to the power of, here you have cos square x, and you know that it is equals to 1 minus sine square x is equal to 30. And in the next step we will simplify the terms, and you get 3 to the power of 4 times of sine square x, plus here we multiply this 4 on both of the terms, and you get 4 minus 4 times of sine square x is equal to 30. In the next step we use the exponential law in the second term, and we will simplify the term as 3 to the power of 4 times of 3 to the power of minus 4 times of sine square x is equal to 30. And here you see that the exponent of this term is negative, so that when we take it into the down, so it will be positive, and we will write it as 3 to the power of 4 times of sine square x plus 3 to the power of 4 over, here it is negative, so when we move down, so it will becomes positive, and we write 4 times of sine square x is equal to 30. And now we convert this trigonometric equation into the simple polynomial form, so that here we take y is equal to 3 to the power of 4 times of sine square x. So when you put y is equal to this term, so you get the output in the form of y plus, here you have 3 to the power of 4, so it is equals to 81, and over 3 to the power of 4 sine square x, it is equals to y, and whole equals to 30. So this is the polynomial form. In the next step we will multiply y on both sides in order to eliminate this y, so that we will multiply y on both of the sides, so that you get the output in the form of y square plus, here these are gone, and plus 81 is equals to 30y. And after that we make the factors of this equation. So first we rearrange y square, here we move 30y in the left hand side, so it will becomes minus 30y plus 81 is equal to 0. So now we make the factorization of this equation, so we make factor, these factors are y square minus 27y minus 3y plus 81 is equal to 0. So here we take common y from the first two terms, and you get y times of y minus 27, and here we take common minus 3 and you get y minus 27 is equal to 0. So now we take common y minus 27 from both the terms and you get y minus 3 is equal to 0. So here we have two cases. The first case is we take y minus 27 is equal to 0, and the other case is we take y minus 3 is equal to 0. So here we move minus 27 in the right hand side, you get y is equal to 27, and here you get y is equal to 3. So now we back substitute the value of y. So here we take y is equal to 3 to the power of 4 times of sine square x. So we will put here and you get 3 to the power of 4 times of sine square x is equal to 27, and similarly 3 to the power of 4 times of sine square x is equal to 3. So here you write 3 to the power of sine square x is equal to 27, and we write this 27 as 3 to the power of 3. And now you focus on both of the sides and you see that bases on both sides are same, so that its exponents are equal. So here you write 4 times of sine square x is equal to 3. Similarly, here you see that bases on both sides are same, so its exponents are equal, and you get 4 times of sine square x is equal to 1, and here you get the value of sine square x is 1 over 4. Similarly, here you get the value of sine square x is 3 over 4. So now we take the square root on both of the sides of this term, so that you will get the output in this form. So this square and square root are gone, and here you get the value of sine x is square root 3 over 2 plus minus square root 3 over 2. Similarly, here you get take the square root on both terms, both sides, so these 2 and square are gone, and you get sine x is equal to plus minus 1 over 2. So here you get the two cases, so I can named this as equation number 1 and this as equation number 2. So now I can solve these two equations one by one. So first we solve equation number 1. So this is the equation number 1, and equation number 1 also have two cases. The first is we write sine x is equal to square root 3 over 2 positive term, and similarly the second case of equation number 1 is sine x is equal to minus square root 3 over 2. So before I can move next, I will explain some concept of angles, so that here you know about these quadrants. This xy system has 4 quadrants. This is the first quadrant, this is second quadrant, this is the third quadrant, this is the fourth quadrant. And here you know about in the first quadrant all the trigonometric functions are positive, means sin x, cos x, tangent x, and secant x, cosecant x, cotangent x, all 6 trigonometric functions are positive in the first quadrant. In second quadrant I can write just s. This s means sine and its reciprocal cosecant. Sine and cosecant are positive and all the other trigonometric functions are negative. Similarly, here you write t. So this t means tangent and cotangent are positive and all the other 4 trigonometric functions are negative values in third quadrant. Similarly, in fourth quadrant I can write c. So c means cos and secant are positive and all the other remaining trigonometric functions are negative value. Similarly, in the first quadrant the standard angle is theta. In the second quadrant the angle is theta minus pi, because here you have angle 0, here you have angle pi by 2, here you have angle pi, here you have angle 3 pi by 2, and here you have angle 2 pi. in first circle. So when you can subtract some pi, then you get, sorry, this is the angle is pi minus theta, not theta minus pi. When you can decrease this pi, you get pi minus theta. When you will add some angles in pi, you get pi plus theta. Similarly, when you can subtract someone in this 2 pi, you get 2 pi minus theta. So this is the angles in anti-clockwise direction. Okay, I can write all these angles in anti-clockwise direction. So this table helpful in order to solve the next equation. So here you see that sin x is positive, and we see sin x is positive in first quadrant and second quadrant, because a and s, first and second quadrant. With reference angle, you know about reference angle. The reference angle is the angle with respect to first quadrant. Means we will always take reference angle as positive angle. If you have negative sign, when we take it into the reference, then we means that we just take it positive, because a reference angle must be positive angle, or the angle in first quadrant. So that the reference angle means that you can find the value of this sin x. When we move sin in the right hand side, you get sin inverse square root 3 over 2, and sin inverse square root 3 over 2 is equals to pi by 2. So here you get x is equal to sin inverse square root 3 over 2, and it is equals to pi by 3. So angle in first and second quadrants, the angle in first quadrant are theta, angle in second quadrants are pi minus theta. Here this theta is the reference angle. Here I can write this theta, it is the reference angle which I can find here. So in the first quadrant, implies x is equal to theta, and or x is equal to reference angle, so it is x is equal to pi by 3. And in second quadrant, the angle is x is equal to pi minus reference angle, and reference angle is pi by 3. So it is equals to pi 3 pi minus pi, it is 2 pi over 3. And now you can see that the period of sine is 2 pi, so I can write generally as plus 2 n pi. I can just add the period of sine in both of the equations, which is 2 n pi. So here you have two solutions, which is x is equals to pi by 3 plus 2 n pi, and x is equal to 2 pi by 3 plus 2 n pi. Here you have the two solutions. Similarly, we will get the other solutions in the second case of this question, and the second case is we have sin x is equal to minus square root 3 over 2. So I can solve similar in this pattern, and here you get the reference angle first. So the reference angle is before find the reference angle, I can see that sine is negative, and sine is negative in third and fourth quadrant. So the reference angle is x is equal to, here you have minus sign. I can tell about before, when we take a reference angle, you ignore this negative sign, and I can just take in the positive sign, so that x is equal to pi by 3 be the reference angle. So in third quadrant, you have the angle is pi plus reference angle. So here you get x is equal to pi plus reference angle, and reference angle is pi by 3. So here you get x is equal to 4 pi by 3. Similarly, this is the angle in third quadrant, and similarly in fourth quadrant, you have angle in fourth quadrant is 2 pi minus theta. So you get x is equal to 2 pi minus reference angle and 2 pi minus pi by 3. This is the angle in fourth quadrant. This is the fourth quadrant angle. So when you simplify this, you get 3 to the 6 pi, and 6 minus pi is 5 pi by 3. And similarly I can add the period on these both terms, and you get the other two solutions are 4 pi by 3 plus 2n pi, and x is equal to 5 pi by 3 plus 2n pi. So these are the other two solutions of the given equation. Now I will solve the equation number 2. So the equation number 2 is sine x is equal to this equation also has two cases. First I can write sine x is equal to plus 1 over 2 and sine x is equal to minus 1 over 2. Now here you see that again this sine x is positive and positive in first and second quadrant, so that it is positive in first and second quadrant with reference angle. So the reference angle here is, the reference angle is x is equals to sine inverse 1 over 2. So the value of sine inverse 1 over 2 is pi by 6. So this is the reference angle which I can use. Now in first quadrant, you know that in first quadrant the angle is the value of angle in first quadrant is only theta, and in second quadrant we have pi minus theta. So I can write here, so x is equal to reference angle, this is the first quadrant, and in second quadrant you have x is equal to pi minus reference angle, so pi minus pi by 6. So you get here x is equal to 5 pi by 6. And now again you see that the period of sine is 2n pi, so we add period on both of the terms and you get the other two solutions are pi by 6 plus 2n pi, and x is equal to 5 pi by 6 plus 2n pi. So these are the two other solutions of the given equation. So now we solve the remaining part of this remaining case. So here we have sine x equal to minus 1 over 2. So you see that sine is negative and it is negative in third and fourth quadrant. So with reference angle, here I can use reference angle this, x is equal to pi by 6, so that the angle in third quadrant implies that x is equal to pi plus reference angle and pi plus pi by 6, so it will becomes 7 pi by 6. And similarly angle in fourth quadrant is 2 pi minus pi by 6, and you get 11 pi by 6. So that we will add the period of sine on both of the terms and you get the other two solutions of the given equation are x is equal to 7 pi by 6 plus 2n pi, and x is equal to 11 pi by 6 plus 2n pi. So these are the other two solutions. So here you have 8 solutions of this problem, and this is our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.